we're talking about today is melting. Does anyone have an idea of what melting is?
Something changes the state.
Okay. No, I really like that. So it's changing state. What states do you think of when you think about melting? Liquid. Do y'all think of any other states? Solid. Yeah. Okay. So yeah, when a solid is turning into a liquid, it's typically what we think of when we think about melting. So how does a solid turn into a liquid? Heat. So when heat's applied to a solid, Alex. So when heat is applied to a solid, it causes it to melt into a liquid. But do we know why? Why does heat have that effect on a solid?
It's heating up the molecules.
Yeah, so what does it do to the molecules when they heat up?
Nope. Speeds them up.
Speeds them up. So why would the molecules speeding up turn a solid into a liquid? So good question. Yes, they move around. So when the molecules heat up and they start moving around, they lose attraction to one another, so they're not like as tightly bound, which helps it turn into a liquid state.
Could you repeat that question? Why do the molecules... Why do the molecules have that effect?
Why does heat have that effect on molecules?
Why does heat have that effect on molecules?
Or what effect does heat have on molecules? It was along those lines. Okay, so what type of things do y'all think about that melt?
Ice.
Ice cream. Okay. Ice.
A popsicle.
Popsicle. Okay, all of these things are frozen. Do y'all think of anything that's not already frozen that melts?
Cheese melts.
Cheese does melt, yeah, it does. Well, you can.
Yeah, in the microwave.
Yeah, I guess it gets yeah, so metals. Do you think that it takes the same amount, the same temperature?
No.
So why do you think the melting point, which is the temperature it needs to be at, varies for different?
Because the initial temperature needs a different amount of heat to speed up those molecules more.
Yeah, because some molecules might be more like attracted to each other and tightly bound. So, so what would take more heat to melt? Ice or cheese? Sally said cheese. Yeah, so cheese would take it. Okay, so okay, so one of the things that was in our prompt for directions was we were given a list of different items and scenarios, and I'm going to read them off to you, and I want you to tell me if it's melting or if it's not melting. So, putting a bowl of frozen ice cream in the sun.
Melting.
Okay. Sawing wood to make sawdust. Dissolving salt in water.
Not melting.
Okay. Adding a Lifesaver candy into a glass of warm water.
Not melting.
You said warm though.
But it's not melting.
That's a good one.
Think of like the saliva, that's
Okay. But your tongue has a little warmth to it.
but that's not melting, it's dissolving.
Okay, so you're thinking that since the water's warm, then maybe. Does anybody else think that maybe it could be melting?
No, just her. Just her.
Well, at first when I read it, the fact that it said warm water threw me off too. So I was thinking, well, maybe. But I think I ended up deciding that it's just dissolving. It ends up, I think I ended up saying it was dissolving. So water evaporating from a pan.
evaporation.
So, heating up water, you're adding heat to the water, which is moving those molecules. When you evaporate water, what does it turn into? What's the amount of gas? So, can something liquid melt into a gas?
It's not going to
No. So, melting is strictly from solid to liquid. Dissolving a sugar cube in a cup of hot tea.
No.
Pouring vinegar on baking soda. Sucking on a lollipop.
Not melting.
Yeah. At first, I thought about it because I was thinking, well, the solid turns into a liquid. And then I realized it was probably some of these I was really overthinking. And then, of course, holding an ice cube in your hand.
Melting.
How many more? What do I need to work on?
Higher order. Follow up. Why? Ask why for every one of those questions.
Okay. So,
Ask to evaluate why a lollipop dissolving in your mouth is not melting.
great, yeah. So, when we were talking about, let's see, both the adding a lifesaver candy into a glass of warm water and then the sucking on the lollipop, even though the solid is turning into a liquid, why would that not be melting? Why is that? Why are we saying that that's dissolving instead of melting? Everything when it's made of, when it's made of salt can
So how can our senses distinguish and classify
yeah, sorry.
Well, I couldn't get her.
Trying to figure out why isn't sucking a lollipop not melting or putting lifesaver.
Yeah, because we have one, it was like adding the lifesaver. He was talking about how with the prompt, that was one that kind of threw me off because it said adding lifesaver candy to a glass of warm water. The warm water kind of threw me off. And I was like, well, the lifesaver does go from solid to liquid, but then I had to process that it's not necessarily melting, it's just dissolving in the water. So I was trying to get people so I was trying to get people to try and explain why we're finding it that it's dissolving instead of melting, even though it's a solid turning into a liquid.
I don't think it's necessarily melting because it's not turning into a liquid, it's turning into, yeah, it's like mixing with, like when you put it on your tongue, it's mixing with your like saliva.
so you can observe
And then it turns into a liquid.
And you can't hear it. That is.
Yeah, heating it
So
up
do you
is
think
not-
that that's a quality of some melting something that it can then return to a solid again?
so chemical
I would think that the reason it's not melting and it's dissolving is because when something's melting, what are you applying to it? Heat. Are you adding anything else to it to make it melt? No, you're just adding heat. So
when do chemicals
in this scenario, you're not just adding heat, you're also adding another factor, which is the water. So I think that would be why it's how many more? Because I'm
You only have 1 minute.
We need follow-up questions.
okay, got you. We're good. So, what are the 3 different states of matter that we know about?
so that means our
Okay, and then so when we talk about melting, we're talking about which 2 states
Solid and liquid.
and what's happening.
Heat is applied and it's heating up the molecules, it's speeding them up, and it's applied to
Okay.
You're doing good.
problem?
I'm thinking about what I already said. Okay, so we talked about how different items probably have different melting points.
You got we'll give you one more minute just to wind up the discussion and recap the discussion, okay?
Why are we saying that different items might have different melting points?
Because some things are more attractive.
So, probably because their molecules are more tightly attracted, so therefore it takes more heat to get those molecules to move past each other to start to liquefy. So we talked about like how the most basic thing that we think of when we talk about melting is the ice cube melting. What do you think the like melting point is of ice? What temperature do you think it needs to get to melt? Any guesses?
Below freezing.
Oh, freezing. Oh, freezing.
I mean above freezing.
All right,
So anything above 32.
time's up.